Hi, I'm Charles Kaplan, professor at the State University of New York at Old Westbury, and this is the third video I'm doing on the quotient rule, and there will probably be about 2 or 3 more videos on the quotient rule. This one, works on just the one particular problem here because it's going to take a little time to work through it and show it to you. But again, students think of the quotient rule as, a little bit intimidating, and maybe it is, but you'll see that it's a relatively easy process, and with a little bit of practice you can work through it and master it in no time, I think. So before we start, I just want to take you through the process of the quotient rule. So we have this fraction f with 2 functions in it, f of x over g of x, and in order to differentiate it, the quotient rule says we take the derivative of the numerator and we multiply it by the denominator, and we subtract off the derivative of the denominator times the numerator and divide it all by the denominator squared. And again, if you saw my earlier videos on the quotient rule, one of my students came up with this notation. She said, well, you take the derivative of the numerator times the denominator, n prime times d, subtract off the derivative of the denominator times the numerator, d prime times n, and divide it by d squared, the denominator squared. And that's it's a much more concise notation. It was clever, and I should tell you about it because I think that it deserves some respect. She came up with something good. Okay, so let's work on this problem. This is the problem in the second video that I skipped over because I knew it was going to take a little bit of time, and I didn't want to worry about how much time I had with this problem. Okay, so let's get to it. So let's differentiate g prime of x. Well, we take the derivative of the numerator, well, that's 2x, times the denominator, 1 plus, let's write this as x to the 1/2. Let's rewrite this thing as x squared over 1 plus x to the 1/2. How's that? So it's 2x, 1 plus x to the 1/2, and we're going to subtract off the derivative of the denominator. Well, the derivative of the square root of x, it's a half x to the negative 1/2, but let's show you how that's done. Let's take a separate piece of paper. So we have y equals the square root of x, which is equal to x to the 1/2, and we want to differentiate that. So it's just a product rule problem. We multiply, bring the half out front, a half x, and then we're going to subtract 1 from the exponent. But we know that 1 is equal to 2 over 2. So 1 over 2 minus 2 over 2 is negative 1 over 2. And that's it. That's the derivative. We can kick this down into the denominator so that y prime becomes 1 over 2x to the 1/2, which is 1 over 2 square root of x. I think in this problem, let's get this out of here. I think here, let's see, what shall I do? I think I'll do this. A half x to the negative 1/2, and we're multiplying it by the numerator, x squared, all over the denominator squared. Alrighty. Let's do our multiplications, distribute and combine where we can combine. So g prime at 2x times 1 is 2x. 2x times x to the 1/2 is 2x to the 3/2 minus, well, let's see what we've got going here. We know that this is the same as 1 over 2x to the 1/2. So if we take 1 over 2x to the 1/2 and we multiply it by x squared, we get x squared over 2x to the 1/2. So let's do that. Minus x squared over 2x to the 1/2 over the denominator squared. Okay. Let's lift our parentheses, and I think we're going to do two things here. We've got this going on over there, right? So I'm going to pull the coefficient out. Half times x squared over x to the 1/2. But x to the 1/2 goes into 2, and so we've got a half x to the 3/2, right? If we're dividing, with the same base, just different exponents, we subtract the exponents. So 2 minus a half is 1.5, which is 3/2. So this thing becomes a half x to the 3/2. So that's what I'm going to put in for this here. So we have 2x plus 2x to the 3/2 minus a half x to the 3/2 over 1 plus the square root of x squared. And now I can take 2x to the 3/2 minus a half x to the 3/2, and I can subtract them. And I get 1.5 x to the 3/2, which is 3/2 x to the 3/2. So let's do that now. 2x plus 3/2 x to the 3/2 over 1 plus the square root of x squared. Well, this is a perfectly legitimate, sound derivative. But if you see what's going on here, we have x in both terms in the numerator, and we can do a little factoring, and I think it'll clean it up a little bit. In this particular case, I think it'll clean it up a lot. So let's take a look. Okay. We can factor out 1/2 x, so let's do that. A half x times, well, a half x times what is equal to 4x? Well, a half x times 4, right? If we take a half x and we multiply by 4, it becomes 2x. Plus, a half x times what is equal to 3/2 x to the 3/2? Well, that's 3 times x to the 1/2. Right, if we multiply a half x times 3x to the half, we get 3/2 x to the 3/2, and that's what we have up there. Divided by 1 plus the square root of x squared. And now this half in the numerator is just a coefficient. I can pull that out and move that out front. So let's do that. We have a half times 4 plus 3x to the half. Whoops. Oh, I made a mistake here. So let me pull this up. It looks a little sloppy, but sorry about it. See? That's what happens when you work these things on the fly. So we have a half times, let's see, let's put the x, 4 plus 3x to the half over 1 plus the square root of x squared. Okay. I really don't like looking at that thing. So you know what I'm going to do? I'm just going to cover it up. This is a cover-up. Okay. Let me... There we go. How's that? See, this is how we... You'd never know I made a mistake now. How's that sound? Look. Okay. So, we have a half times x times 4 plus 3x to the 1/2 divided by the denominator we had. And now we can take the 1 up here and the 2 down here. So let's do that. G prime x is equal to x times 4 plus 3x to the 1/2 divided by 2 times 1 plus the square root of x squared. And if we wanted to, we can make this into a square root up in the numerator. So we get g prime of x is equal to x times 4 plus 3 square root of x divided by 2 times 1 plus the square root of x squared. If I really felt ambitious, I would rationalize the denominator, multiply by a conjugate, but I'm not going to bother with that. Here we go. This is the really nicer looking a plus derivative solution, and it's this compared to the original one we had. Let me fold this over. So, actually, I can cut this right through. Let's do that. Okay. So there's the 2. This is the A answer. This is the A plus answer for the derivative, I would say. And both of them are perfectly acceptable. So anyway, that's the only problem that I'm going to cover on this, the third video on the quotient rule. Now bear in mind, the next few videos are going to be quotient rule videos, but they're only going to deal with trig functions in the quotient rule. So I'm sure you're differentiating and working with trig functions in your class, unless it's a business calc class, and then you may not be. In any event, the next few videos will deal exclusively with the quotient rule and trig functions, okay? So again, this is Charles Kaplan, and I wish you all, I hope you found the video helpful, and including my cover-up, and I wish you all good health, happiness, long lives, and a lot of good luck along the way. Bye-bye.